All right, welcome back, friends. Okay, so today is our second demo session. Okay, so most probably by tomorrow we'll start our regular sessions actually. And if you remember, yesterday we started one of the most important topic in our CCNA, that is IP addressing, right? We have just seen the basic introduction of IP address yesterday. So let us try to go a bit more deep into this IP addressing concept, and let us try to learn this concept in the best way possible. Remember, friends, I told you IP address is the backbone of every computer network. The computer network can be a private network or public network, physical network or a cloud network, whatever. If you're good in the concept of IP addressing, friends, you will be very good in all the other things that are related to the networking services. Okay, so just try to learn this concept in the best way possible. Just try to learn literally everything about IP addressing. CCNA is the only course where we learn in details of this IP addressing actually. In other courses like Linux server administration, Windows server administration, cyber security, cloud computing, DevOps, ethical hacking, everywhere we are using IP addressing, but where we are learning IP addressing, we are learning IP addressing in only CCNA. Done? Now, so let us have basic revision. What we did yesterday. We know what is IP. IP is Internet Protocol. It is a number that must be assigned on every device, right? Without IP address, communication is not possible. I repeat, without IP address, communication is not possible. See, as of now, we are able to, uh, have this particular online session here. One of the reason is there is a IP address in your machine, there is a IP address in my machine. I may be using a laptop or a desktop, you may be using a laptop, desktop or a mobile phone, but there is a IP address in every machine actually. That is the reason we are able to connect to the internet. Without IP, communication is not possible. Okay. So IP address can be used as a identification of that machine, as well as by using the IP address, we can, identify the location of that particular machine. Over the internet or within the company, we can identify this particular machine belongs to which particular department. So all these things are possible by using this IP address concept here, friends. Done? Now, there are two versions we have in IP address. One is your IP version 4 and the other one is IP version 6. IP version 4, like I said, is said from like 1970s and early 1980s. But coming to IP version 6, IP version 6 is designed in 1997 and 1998. It was introduced in 1997 and 1998. I remember what was the reason for introducing the IP version 6? In IP version 4, we have some limited numbers. But see, when I say limited numbers, actually, I'm talking about more than 4 billion numbers. All right, more than 4 billion numbers are there in IP version 4, but still they are considered as limited because the concept of internet is such a huge concept here, my friend. Whenever someone is connecting to internet and accessing some application, the person should have the IP address and the internet application should have an IP address. So internet is huge where, lakhs and lakhs of computers are connected, lakhs and lakhs of, not lakhs anyway, some millions and millions of computers are connected and millions of applications and web servers and all the other servers are running over the internet. So everywhere you need IP. So 4 billion plus IP addresses is not at all a big number, my friend. Okay, actually from these 4 billion plus numbers, there are more than 1 billion plus numbers which are not usable. So if you go in more technical things here, less than 3 billion IP addresses are actually usable in IP version 4. Again, in that there is something called public IP, private IP. So overall, the usable numbers are way less than actually 3 billion numbers. Okay, so we'll see all the other things why we are not using more than 1 billion numbers, where we are using all the other numbers. But as of now, this is what the IP version 4 offers us. It offers us approximately 4 billion plus numbers. Whereas coming to IP version 6, wow, IP version 6 is too big to imagine, right? This is the total number of IP addresses we have in IP version 6. How many it can be? It can be some trillions and trillions and trillions of numbers. There can be some trillions and trillions of numbers. Remember yesterday I told you, if you take only one IP address for your laptop, let's say you're taking some million IP addresses, I'm taking 1 million IP addresses, some other person is taking 1 million IP addresses. Still in IP version 6, there will be some trillions and trillions of IP addresses which will be available for free. So IP version 6 is a very big number actually, my friend. Okay, so we have many number sets. So these numbers most probably will be sufficient for many centuries to come. Okay, so this is such a big number. Okay, fine. Then we have seen certain, binary, decimal, hexadecimal numbers. Remember, binary numbers are zeros and ones. Hexadecimal numbers are, okay, binary numbers are 0 to 1s, and decimal numbers are numbers that are there between 0 to 9. These are your decimal numbers, and hexadecimal numbers are all the 0 to 9 numbers, and we have A, B, C, D, E, F, some alphabet. So these are your hexadecimal numbers. So IP version 4 and IP version 6, we use these three numbers: binary number, decimal number, and hexadecimal number. Now let me make one thing very clear here. IP version 4 or IP version 6, it is designed by using binary numbers. I repeat, IP version 4 or IP version 6, it is designed by using binary numbers. But IP version 4 is presented to users by using the decimal format, and IP version 6 is presented to the user by using this hexadecimal format. This is one of the difference actually. IP version 4 for a user, that is for you and me, is in decimal, and for a user, IP version 6 is in hexadecimal. Hexadecimal means we can see some alphabets A, B, C, D up to F. That is your hexadecimal format. Okay. Now, the most important part of IP address that we need to understand actually is the binary and the decimal numbers. What are these binary and decimal numbers, and how to convert the binary numbers to decimal and decimal numbers to binary? If you know this concept very well, friends, binary, decimal number, decimal, binary number, you can literally understand everything that is there in this IP addressing concept. And if you're not able to catch, or if you're not able to understand the differences between binary and decimal number, or if you're not able to understand how to convert a binary number to decimal and decimal to binary, you simply cannot understand anything in IP addressing, friends. So we'll just try to spend a bit more time actually in understanding the binary and the decimal number format. Okay. Fine. So I can see two new people here. One is Kevin and the other one is Mahesh. I think for both of you, this is the first session, friends. Yesterday, there was a session actually. We have just seen basic introduction of IP addressing. So whatever I have, revised till now in last 10 minutes, that is what we have seen yesterday. Fine. And today we'll just try to go a bit more deeper into IP addressing concept. Okay, so in case if you're not able to understand anything, I'll be available for you. Hopefully, I can take some extra sessions for you, and I can just try to cover up everything. But I'll make sure you'll just understand everything, because I have not done much actually. I have just started the session yesterday. It was just a basic introduction session of IP addressing. Today, we'll just try to go a bit deeper into IP addressing. Okay, fine. Anyhow, the chat box is always open here, friends. Whenever you have any doubts, you can always send your queries in the chat box so that I can address every question of yours. Okay, fine. Now, see here, friends. IP version 4 is a 32-bit number, and 32 bits are divided into 4 octets, and each octet is separated by a dot. This is the format, or this is the design of IP version 4. I repeat, when they were designing the IP version 4 option, IP version 4 number, they took how many bits here? 32 bits. Okay. Now, what happens if they take 32 bits or 64 bits or 128 bits? What exactly these bits represents actually? This is a very simple and very important question. Now, let me just open a paintbrush for you, and let me just explain things in much easier way. See, when I say IP version 4 is a 32-bit number, so technically it will be all zeros, ones, ones, zeros, zeros, ones. It will be something like this. So 32-bit will be something like this. So these are totally 32 bits here, right? So IP version 4 is a 32-bit number divided into 4 octet. What is the octet here, friends? Octet is something like, collection of 8 bits, right? So octet is collection of total 8 bits. So IP version 4 is a 32-bit number divided into 4 octets. So when I say 32-bit, like I said, friends, it will be all ones, all zeros, or it will be a combination of ones and zeros. So these are actually your 32-bit numbers. Okay. Now, if they're not dividing 32-bit numbers, 32 bits into like 4 octet, your IP address will be something like this. It's a bit difficult number to remember, or if it's a bit difficult number to assign, right? But what if I say the number is 192.168.159.169? This makes more sense, right? So they have taken the 32 bits, but they have divided these 32 bits into 4 octets, because there are many other things that are there in this IP addressing. Like there is something called network portion, host portion, network ID, broadcast ID, public IP, private IP, subnet mask, customized subnet mask. So there are many things. All these things we will cover. But as of now, why these 32 bits are divided into 4 octets? They are divided into 4 octets because it makes the IP address looks better, and it makes all the other things that are involved in the IP addressing concepts easy to understand. So 32 bits are there. 32 bits are divided into totally 4 octets. Each octet contains totally 8 bits. So the bit can be either 0 or it can be 1. Done. This is one thing that we need to understand carefully. Now, the next thing what we need to understand here is, if there are 32 bits available, what exactly is the advantage we have, or what exactly it is trying to explain us? See, for example, if I go with only 2 bits, let's say 0, 0. There are only how many bits here? I have just taken 2 bits here. So if I take only 2 bits, the question here is how many combinations I will get here. So 0, 0 is one combination, 0, 1 is one combination, 1, 0 is another combination, 1, 1 is the one combination. So totally how many combinations we got here, friends? We got totally 4 combinations. So if there are 2 binary bits available, we will get 4 binary combinations. Okay. Now let us go to one more example. Let us take one more example here. Let us say 3 bits. If there are 3 binary bits here, friends, then how many combinations are possible? So if there are 3 binary bits, then total 8 combinations are possible. I repeat, total 8 combinations are possible. We will get 8 unique combinations. And what if there are, let us say, 4 binary bits? Starting will be 0, 0, 0, and the last combination will be 1, 1, 1. But in total, how many combinations are possible here? Can we just calculate by writing 0001, 0010, something like this? It will be a bit difficult to, calculate like how many combinations we are getting here, right? I can say the answer, that is 16. We'll get total 16 combinations. But is it possible for us to calculate all the 16 combinations by writing down the unique combinations there? No, right? It will be difficult. So what if there are 32 bits available? Can we write down all the 32-bit combinations here? No. So the easy method or the easy formula is, if you have total 2 bits, it will be 2 power 2. If you have total 3 bits, it will be 2 power 3. If there are 4 bits, 2 power 4. If there are 5 bits, 2 power 5. If there are 32 bits, 2 power 32. By using this power value, we can calculate like total number of combinations are how many if you have this many bits. So I am taking base as 2 here, 2 power 2, 2 power 3, 2 power 4. This 2 is number of bits, this 3 is number of bits, this 4 is number of bits, 5 is number of bits, and 32 is number of bits. But the question here is, why the base is 2 for every number of bit? See, base is 2 because the binary numbers are zeros and ones. Right? There are only 2 numbers, right? 0 and 1. So I have to take base as 2, then I have to go with this power value. So 2 power 2 will be how much? 2 power 2 will be 4. 2 power 3 is how much? 2 power 3 is 8. 2 power 4 is how much? 2 power 4 is 16. 2 power 5 is how much? 2 power 5 is 32. And what about 2 power 6? 2 power 32 actually. 2 power 32 will be this number. 4294967296. This is your 2 power 32. Let me just show you in calculator once. So if I say 2 power 3, it is how much? 8. If I say 2 power 4, it is how much? 16. Now, if I say 2 power 32, it says done 4294967296. That means if there are 32 bits in this particular IP version 4 addressing scheme, you will get totally 4 billion plus IP addresses. Okay, so this is the reason we got that many IP addresses. And coming to IP version 6 here, friends, like I said you, there are totally 128 bits here, right? So 2 power 128 will be how much? This number, some trillions and trillions and trillions of numbers. Okay, so this is the reason we have 32 bits in IP version 4. And maybe, when they designed this IP version 4 in 1970s and early 1980s, there was no concept of internet. So if someone says 4 billion IP addresses are possible in IP version 4, that was a huge number, right? Back in 1980, 1979, 1981, it was indeed a very big number. But because of this concept of internet, this number become like very small number, because over the internet everything is there on IP address, right? Every application, every web server, every game server is running on a IP address, or it has at least one IP address. So now these 4 billion numbers are no way sufficient to run all the applications and all the web servers for the internet. So that is the reason they have introduced this IP version 6. Okay, fine. This is one thing we need to understand. Now, now the second thing that we need to focus here is the binary to decimal conversion. Like I said, you friends, IP version 4 is actually a binary number, right? It is indeed a binary number for a machine. This is your IP version 4. But as a user, can we understand anything about this IP version 4 here? It is only 11001010 something like this. We cannot understand anything here, right? We simply cannot understand anything. So as a user, IP version 4 we will use in the decimal format. But see, we are not a users here. We are not a normal users here, right? We are the administrators. We are the server administrator, network administrator, cloud administrator, DevOps administrator, cyber security administrator. Maybe we are ethical hackers in future. Who knows, right? But as the administrator, as all these administrators, whatever I said, we need to know, like, what exactly is happening behind this IP address. So if you know the conversion of binary and decimal, decimal and binary, like I said, friends, you can literally understand everything. So please take this conversion very seriously. The next 6, 7 classes will be very easy for you if you are very good in this conversion. We are not learning this conversion just for sake of learning. We are learning this conversion because we have to learn the IP addressing concept perfectly. Okay, so these are the binary numbers, friends. Let us try to convert these binary numbers into decimal so that we can understand literally everything about the IP addressing concept. Okay, fine. Now let me take few examples here to show you like how we can convert the binary numbers into decimal. Binary decimal conversion. Binary number to decimal conversion. Maybe you have learned this binary decimal conversion sometime in your school days actually. Maybe in your primary school, upper primary school, 7th standard, 8th standard sometime. So if you know the conversion, well and good. If not, then we have to again learn it, or in case if you forgot it, just try to repeat or revise it. Okay, so that makes the IP addressing concept more easier. Now, how many binary numbers we will convert into decimal? See, binary numbers can be 0, 1, or 3 binary bits, or 4 binary bits, 10 binary bits, 32 binary bits. I can take any number of binary bits. For example, let's say this is also a group of binary bits, right? Maybe I have taken around 20 binary bits. I can convert these 20 binary bits into decimal, or I can simply convert these 4 binary bits into decimal. This is not 10,100. This is 10100. I can convert this, or I can convert these 6 bits into binary. I can convert 7 bits into binary. I can convert 8 bits into binary. So I can take any number of bits and I can convert those number of bits into binary. But you know what I'll do here, friends? I will not take any number of bits. I'll just go with 8 bits. Now, why I'm using 8 bits here? The reason is IP version 4 is a 32-bit number here, friends. 32 bits are divided into 4 octet, and each octet contains totally 8 bits. So that is the reason I am using 8 bits and converting this 8 bits into decimal. But like I said to friends, you can take 73 bits in sequence and you can convert those 73 bits into decimal. Not a big deal. Okay. So let me just take 8 bits here and let us see how we can convert these 8 bits into 8 binary bits into decimal. So I'll just randomly take some bits here. Let's say 1, 1, 0, 0, 0. So this is my combination, friends. How many bits I have taken here? I have simply taken totally 8 bits. Fine. Now, how to convert these 8 binary bits into decimal? What will be the decimal value? So very simple here, friends. Listen carefully, please. You know, whenever you're converting the binary bits into decimal, we need to make sure we know the bit values. Every bit has a bit value. I repeat, every binary bit has a bit value. So this bit is actually counted as your first bit. This is your second bit, third bit, fourth bit, fifth bit, sixth, seventh, and this is your eighth bit. So every bit has a bit value. Okay. So let us try to understand what are the bit values here. The bit value of this first bit is actually 1. The bit value here is 2. This bit value is 4. So whenever you are converting a binary number into decimal number, just note down the bit values. And remember one thing, the bit values will simply double every time. So 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, it will be how much? 8. Done. 8 plus 8, 16. 16 plus 16, 32. 32 plus 32, 64. 64 plus 64 is 128. So see here, friends, every bit has a bit value. So the first bit value here is 1. This is 2. This is 4. This is 8. This is 16. This is 32. This is 64. This is 128. Clear? Every bit has a bit value. What if there is one more bit? The bit can be 0 or it can be 1. It doesn't matter. Don't worry about the bit is 0 or 1. If there is one more bit here, there is a 9th bit. Can you please tell me what will be the bit value of that 9th bit actually? Right now we have only 8 bits, right? But in case if there is one more bit available, there is a 9th bit. What will be the bit value? Okay, Praveen, I saw your message. I'll come to your message hopefully at the end of the class.
256.
Okay, fine. So the next bit value is how much? It is 256, right? And if there is one more bit available, 256 plus 256 is 512. One more bit available, 512 plus 512 is 1024. So like this, bit values will simply double. Okay, so right now we have only 8 bits here. So we just need to see the 8-bit values here. Okay, let me just check this again. I'll just write down all the bit values here now. 128, 64, 32, 16, 8, 4, 2, 1. Okay, so all these are bit values of these bits. Now, the second thing I need to calculate here is, or the second thing I need to see here is, wherever the bit is 1, it is a on bit, and wherever the bit is 0, it is a off bit. That's it. Zeros means off, ones means on. I repeat, if the bit value is 1, it is a on bit, and if the bit value is 0, it is a off bit. So how many bits you can see which are ones here? This bit is 1 and this bit is 1. Now what I have to do? What is this bit value here? 128. What is this bit value here? 64. 128 plus 64 will be how much? 128 plus 64 will be 192. So 192 is actually your decimal number of this binary group of bits. 192 is your value now. That's it. Okay, hang on. Let me just take one more example here. Things will be more easier actually if I just show you like 2, 3 examples. So let us say here the bits are like this: 1, 0, 0, 1, 0, 1, 0, 0, something like this. Any random bits. Okay, any 8 random bits here. Now what I have to do here, I just need to see where the bits are ones. Where the bits are ones, this bit is 1, this bit is 1, this bit is 1, isn't it? So what are those bit values actually? Those bits values are 128 plus 16 plus 4 equal to your decimal value. So we just need to see wherever the bits are ones, see the bit value and you will get your decimal value if you just add all the bit values. So 128 plus 16 will be how much? 144. Yeah, 144 plus 8 will be how much? 148. So see here friends. This is 148. Done. Simple. One more. Let's see one more example here. I'm just taking 8 binary bits here. Randomly, I'm taking 8 binary bits. 1. Okay, I'll start now with 0. Let's say 1, 1, 0, 1, 0, 1, 1. Equal to how much? What I have to do here, friends? I just need to see how many bits are ones. Let me just open a calculator here. Simple way of, calculating or converting the binary bits into the decimal bits, right? We just need to see where the bits are zeros and where the bits are ones. Okay. So in this example, I need to take 64 plus 32 plus 8 plus 2 plus 1. It is how much? It is 107. So how many bits are on here? 64 bit is on, 32 bit is on, 8 bit is on, 2 bit is on, and 1 bit is on. So it is how much now? It is 107. This is your binary to decimal conversion, my friend. Okay, I hope you're able to follow me here, friends. And see, if you know any other way of conversion, please stick to that conversion actually. This is one of the easy way of converting a binary number into decimal. But this is not the only way. There are multiple ways available actually in which you can convert a binary number to decimal number. So like I said, you friends, if you are comfortable with any other way of conversion, you just need to know how to convert these numbers, binary to decimal, decimal to binary. That's it. Okay. Now, I'll just try to write down some binary, bits here. Can you please try to convert them into the decimal numbers? Okay, let me do one thing. Okay, so there are many bits or many conversions I have added in this, file, but try to go with these conversions. Just try to convert the last binary bits or binary conversions, this one. Okay, hang on a second, please. Let me arrange everything properly. Okay, fine. So can you please convert these bits? Just start from here. 1, 2, 3, 4, 5, 6. There are 6 combinations here. Take your time. You have, couple of minutes. Just try to convert this 6 binary group of bits into decimal. Okay, the first one is actually 0, 0, 0, 0, 1, 1, 1, 1. You know how to convert these bits into decimal now? You have the bit values here. You just need to see wherever the bit is 0, ignore the bit, and wherever the bit is 1, just try to count that particular bit and add all the bits actually. Just do the addition there, you will get your decimal value. That's it. Okay, so take your time, friends. You have like a couple of minutes to do this conversion. Like I said, you friends, if you're good in this binary decimal conversion, you will be very good in everything that is there in the IP addressing and the advanced IP addressing concept. And if you're good in this IP addressing concept, you can be very good in all the other technologies that you're trying to learn, like cloud computing or cyber security or ethical hacking or server administration or networking or whatever. So just try to take this conversion very seriously and just try to convert this. Okay, you have a couple of minutes for this. Good luck. Okay, I hope you're able to do it, friends. You have like 1 more minute to go. Once we do this conversion, actually, we'll get a very important point about this IP version 4. We'll understand one of the most important points of IP version 4 once we do this binary decimal conversion. Okay, so let us see the answers. I hope everyone has done the conversions there. So I'm sharing the screen now, so hopefully you can see the answers there and just try to cross-check everything. I've already received the answers from a couple of people actually. Yeah, Shravuf, exactly. Praveen also sends me a message here. Let me just open it once. Yeah, fine. Exactly. Now let me just share the answers. This is what it is, right? Okay, so these are your binary to decimal conversions. So if you have started from this number, first is 15, second is your 240, then it is 170, then 85, then 0, and it is 255. These are total, I think, 6 conversions you have done there, right? Binary to decimal conversions. Okay, I hope you are comfortable with this binary decimal conversions. If you can just write down these bit values, it's not a big deal to convert any binary combination, right? It can be 8 bits or it can be 20 bits, it can be 3 bits, whatever. You just need to write down the bit values there. It will be easy for you to convert all the binary bits into their respective decimal number. Now, see here, friends. Can you see I have highlighted 2 binary conversions here actually? One is this one. All the binary bits here are zeros. And the second one is this one. All the binary bits here are ones. Now what it says here is if all the binary bits are zeros, then the decimal will be 0. If all the binary bits are ones, then the decimal is 255. So if all the binary bits are zeros, obviously it is 0, right? Nothing else. But if it is all ones, that means 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 will be how much? It will be 255. So the concept here is the IP version 4 is designed by using 32 bits, and these 32 bits are divided into 4 octets, and in every octet we will get a decimal range from 0 till 255 only. I repeat, we will get the decimal range from 0 till 255. Any number that is above 255 is considered as an incorrect number. So first octet is 0 to 255, second octet is 0 to 255, third octet is 0 to 255, fourth octet is 0 to 255. That is the range of numbers we can use in IP version 4. So 0 to 255 means how many numbers? 256, right? Because 0 is considered as a usable number. It is considered as a usable number in IP address. So we are not using 1 to 255. We are using 0 to 255. So total how many numbers are there? Total 256 numbers are there, my friend. Okay. So 0 to 255 is usable in every octet. Now let me again go back to calculator once. See here. 256. Why I'm using 256? Because 0 to 255 is how much? 256, right? Now 256 multiply by 256, multiply by 256, multiply by 256. If I just say equal to here, can you see the number 4294967296? Okay, okay. Let me just cancel here. And if I say 2 power 32, sorry, 2 power 32, how much you are getting there? So if it is 0, see here, if it is 0 to 255, that is 256 numbers, or if it is 2 power 32, you will get exactly the same number. So this is your 2 power 32 calculation here, and this is your 256, 256, 256. So at the end of the day, we have this many IP addresses in IP version 4. Okay, so we have totally 4 billion plus addresses in our IP version 4. So see here 192.168.0.1 is a correct IP address. It is a usable IP address because 192, 168, 0 and 1. All the numbers that we are using in these 4 octets are between 0 and 255. But if I go to the second example here, 192.168.0.286, I'm using 286 here. Can I use 286 in any octet? No. If you say 286 in any octet, it is a incorrect number. It is not usable. It will not be accepted by any operating system or any machine. Okay, let me show you practically now. I'll just go to my Windows machine NIC card settings here. So this is the Ethernet card. If I go to the properties of Ethernet card, here I can assign the IP address, IP version 4. So I'll just select the IP version 4. I'll go to properties here. Then let me just assign the IP address as 192.168.0.1. See, all the numbers are accepted in each octet. There is no problem here. 192.160.0.1, all the numbers are accepted. Fine. If I go with the second example, let's say 192.168.0.286. See, once I say 286 here, what it says? It says 286 is not a valid entry. 286 is not a valid entry. Please specify a value between 0 and 255. It says use a number between 0 and 255 only. You cannot exceed 255. 0 to 255 is the range. Now, the big question here is why it is only 0 to 255? The reason is IP version 4 is 32-bit number. 32 bits are divided into 4 octets. Each octet contains totally 8 bits. So the first combination we get here is 0000, and the last combination we get here is 1111. So if you just convert the zeros into binary, it will be 0. And if you convert all ones into binary, it will be 255. And whatever combinations we get in middle, it will be between 0 and 255 only. So this is the most important part of IP address we need to understand here. I hope it is clear. I'll just wait for like 30 seconds. If you have any doubts, we'll see, or else we can move to the next part of IP addressing. Let me just show you one more example here. If I say, let's say 1.2.3.4, no problem. Everything is accepting here. All the octets are, assigned with the number which is set between 0 to 255. But if I say 100 dot 200 dot, if I say 300, see again it says 300 is not a valid number. Use a number between 0 and 255. This is in every octet. As of now, I can say the range of 0 to 255 is for every octet. Okay. Fine. Let me just take 30 seconds break here. If you still have any doubts, we will see. Or else we'll go and see the decimal to binary conversion. So once we are done with these conversions, the remaining things will be much more easier actually for us to understand. Okay, fine. So I hope everything is correct. So let us see the decimal to binary conversion here, friends. I have, written many numbers here actually, but I'll do one thing. I'll just go practically. I'll just take any number and I'll show you how to convert these numbers into binary. Okay, so to convert a decimal number to binary, the first thing you should do here is you should simply write down all the binary bit values. Remember 1, 2, 4, 8, 16, 32, 64, 120. This remains same. Okay, all the bit values will remain same. So let me just show you how to convert a decimal number to binary. But can you please tell me any decimal number between 0 and 255 so that I can show you that number, how to convert that number in binary. Any number from 0 till 255.
240.
240. Okay, fine. So I'll go with 240. 240 is actually a very easy number. Okay, but still I'll show you this 240. Let me just change some font size here. Okay, so 240 is the number. What we have to do here is we just need to write down the decimal number, and with this decimal number, we just need to write down the bit values. And then we have to do subtraction. You know what is subtraction, right? Okay, what we have to subtract here? We need to simply subtract the bit value from the decimal value. For example, imagine instead of 240, suppose I'm using 70. Can I subtract 128 from 70? No, right? 128 is a bigger number, 70 is a lower number. I cannot subtract that particular number. But now what is the number I'm using here? The number is 240. So can I subtract 128 from 240? Yeah, that is possible, right? Now let me just open the calculator here. Let me just arrange everything properly for you. Okay, fine. Now see here, friends. 240 minus 128. How much is remaining? 112 is remaining. Fine. So first of all, I can subtract. So this will become 1. Now, can I subtract 64 from 112? I'm not subtracting 64 from 240. 240 is already subtracted, right? So I need to subtract 64 from 112. So 64 is a lower number. We can subtract it from 112. So I just need to say minus 64 here. How much is remaining here? 48 is remaining. Now, can I subtract 32 from 48? Of course, I can do this, right? 32 is a lower number. So 32 is subtractable. So I just need to say minus 32 here. 16. Can you subtract 16 from 16? Obviously, we can subtract 16 from 16. So once you subtract 16 from 16, how much is remaining now? 0. So what I have to do now? I just need to go with like remaining all bit size zeros. That's it. So this is the way I can subtract a decimal number to its binary value. Job done. Okay. One more number, please. Any other number from between 0 to 255? Like I said, friends, try to keep the chat box as busy as possible. Your chat box, if it is busy, sessions can go too deep actually. Sessions will be more interesting. Okay, fine. I got two numbers here. One is 67, another one is 156. I'll go with both the numbers. Let me just go with 67 first, and then I'll go with 156. Okay, so how to convert 67, that is a decimal number, into the binary number? Very simple here, friends. Let me just open the calculator again. Fine. Can you subtract 128 from 67? No, 128 is a bigger number. We cannot subtract. So it will be 0. Can you subtract 64 from 67? Yeah, that is possible, right? 64 from 67 we can subtract. So 67 minus 64. How much is remaining now? Only 3 is remaining. Can you subtract 32 from 3? No. Can you subtract 16 from 3? No. Can you subtract 8 from 3? No. Can you subtract 4 from 3? No. Can you subtract 2 from 3? Yeah, this is possible. 2 is a lower number, so I can say minus 2 here. I can subtract. Now, how much is remaining here? 1. Can you subtract 1 from 1? Of course, we can do. So once you say minus 1 here, you will get 0. You will definitely get the number as 0 in the last. Okay. Once you do the subtraction of all these bits, you will get last bit as 0. Maybe you will get 0 in the last bit, or maybe you will get 0 in the fourth bit itself. Okay. For example, if I take one more number before I go to 156, let me take a number as 128. Let's say 192. If I take 192 here, see, can we subtract 128 from 192? Yeah, this is possible, right? So this is 1. So 192 minus 128. How much is remaining? 64 is remaining. Can you subtract 64 from 64? Obviously, that is possible. So 64 minus 64 is how much? 0 now. So once you get the number as 0, whatever number of bits are available, all the other bits will be converted into zeros. Clear? All the bits will be converted into zeros. Now let us try to convert 156 into the binary number. Okay, same logic here, friends. Can you subtract 128 from 156? Yeah, this is possible. 128 is a lower number, 156 is a bigger number, right? So 156 minus 128. Remaining is 28. Can you subtract 64 from 28? No. Can you subtract 32 from 28? No. Can you subtract 16 from 28? Yeah, this is possible, right? 16 is a lower number. So I just need to say minus 16 here. How much is remaining, friends? 12 is remaining. Can you subtract 8 from 12? Yes. So minus 8 will be how much? Okay, I said 4, right? Okay. Yeah. No, see, it was 12, right? So 12 minus 8 is how much? 4. So can you subtract 4 from 4? Yes. So 4 minus 4 will be how much? 0. So the remaining 2 bits become 0 and 0. This is the way we can subtract the numbers and we can convert a decimal number into its binary number. If you are comfortable in any other way of conversion, my friend, just try to stick to that conversion. I'm repeating again, you can just stick to that way of conversion. At the end of the day, you just need to know how to convert a binary number to decimal number. That's it. Okay. So just take your time, 30 seconds. Just try to revise everything. If you still have any doubts, we'll just clear everything. And if you need some more conversions, actually, I'll go with the other conversions also. Just try to give me a number between 0 to 255. We can convert this number. Why I'm taking 0 to 255, you know this, right? Because it is a range of numbers that we can use in IP version 4. You can take a number like 735, 735, and that number you can convert in binary. But that is not used in our IP version 4, right? 735 is a number that is not available in IP version 4. That is the reason I'm using numbers between 0 and 255 only. Okay, so take your time, 30 seconds, and let's see what happens. Okay, so I guess no questions here. I think everything is clear now. Binary decimal conversion, decimal binary conversion. So just do a favor to yourself, my friend. Just try to take some binary numbers, random binary numbers, like from 8 binary numbers, and try to convert them into decimal. And take any decimal number from, let's say, 0 to 255 and convert that number into binary. Just try to do more conversions, practicals. It will be more easier for you to understand everything. So from tomorrow, if you just see 8-bit of binary bits without using pen and paper, you should be in a position to say like, okay, if these are the bit combinations, this will be your decimal number. That much perfection you should get, my friend. Especially in the binary to decimal conversions, you should get that much perfection. I'll be sharing this document so that you can go through all the examples that I have written there. But still, just try to do practice. Just try to convert all the binary bits into decimal bits. and decimal to binaries. This makes your IP racing journey very easy and very fruitful. And once, like I said, you're good in this IP racing concept, there is nothing in CCNA that you can say like, oh, it's very difficult to understand. There is nothing in networking which you can say like, okay, it's a bit difficult to understand. Frankly speaking, IP address is the only thing where we need to spend some extra time. Remaining all the concepts will be much more easier for us to understand. But all the concepts are related to this IP addressing concept. Remember yesterday I said, if you want to impress the person, impress the interviewer actually who is taking your interview, if you want to impress with your knowledge, just try to answer good from this IP addressing concept. This is such a big thing in our networking field, as in Linux administrator, as a cloud administrator, as a Windows administrator, okay, as a cyber security guy, okay, and whatever things, everything is hopefully easy if you are good in these conversions. And by the way, thanks for coming. Actually, match is going on. So this is the status as of now. Hopefully we are very close to the victory and the
Yeah.
champion is playing here, right? Fine. Yeah. Anything else, friends? I'm here for like 30 more seconds. If you have anything else to discuss, we'll see this. Else we can stop the session for today. Tomorrow we'll just continue from here.
Why first number is having 1 for the first bit, 0, 1, top. No, 1, 2, 4, no, there.
This
1,
one,
2, 4, yeah, how it came to 1?
this is mathematics, my friend. This is the way we can convert the binary bits into decimal. This is the formula.
No, that I got it.
Uh,
So, see here at all, it came 2 bits, 1 power is 2.
see
2 to
here.
the power is
Yeah,
0
yeah.
is 1, no? How?
This is 2 power 0.
0. Okay.
Anything to the power of 0 is how much? 1. 2 power 1 is how much? 2. 2 power 2. This is the third bit, right? So 2 power 2 is how much? 4.
Yeah. From there I got it. First
Yeah.
only I got confusion. 2
Okay,
to the
okay.
power is always 1. No? Okay.
Yeah.
Okay. Thank you.
Okay, fine.
Thank you.
Yeah, fine. Okay, so
So, what is the course duration?
course duration, Mahesh, is actually 35 to 36 days. Okay, so this is our second day, second demo session. In a demo in the sense, I'm just trying to go a bit slowly here. So this is our second day, and we'll just try to go as deep as possible, but it will take around, 35 days. Okay, so in case if you have any other queries, any other, questions regarding this course or the syllabus or, anything that you need to know, I've just sent the WhatsApp number there. That is my WhatsApp number. You can ping me there. And if you have any doubts, you can simply clear all your doubts there.
So it's been written like 4 months, something like that, in that website. So
No, no,
that's
no.
why,
It's
yeah.
a package for 4 months, Mahesh. Season is 4 months. It's like, too much. I'll explain you what is this 4 months. This is a package where we have courses like CCNA, Linux Server Administration, AWS, and Windows Server Administration. If you are going with this complete package, then probably it will take 4 months. Okay. So let's say for CCNA, let's say 35 days or so. Linux, 35 days or so. AWS, let's say 45 days. So if you go in this way, then it will take 4 months. And Windows Server Administration is actually only a recorded session. So it's up to you like how you're going through the sessions. So overall, it is something like this. And by the way, in this package, we have only CCNA plus Linux plus Windows. If you want to come for AWS, that is a different course. Then you can have a different discussion for that particular course. But as of now, this is the package, my friend. CCNA, Linux plus Windows Server Administration.
So all three will be covered in 35 days, right?
No, CCNA will be covered in 35 days. That is between 8 p.m. to 9 p.m. India Standard Time. Okay. And Linux will be there at some other time. Let's say from 10 p.m. or 9 p.m. or 7 p.m. or some other time. So that will be another 1 hour every day for next 35 days. Or whenever I start the Linux from that day till 35 days.
So
So it is
you'll be
something
the
like
instructor or somebody else will be?
I'll be the instructor for all these three, four
Okay.
courses actually. Windows administration, I'll share my recorded sessions. But coming to CCNA, Linux, and AWS, these are live sessions, and I'll be covering all the things in this particular package: CCNA, Linux, as well as AWS.
Okay.
And every session is recorded here, and all the recordings will be shared with you regularly through Google Drive actually. Okay, so once we finish the session today, maybe within couple of hours, the session will be available for you in Google Drive. You can just go through the session. Again, in case if you need, or in case if you miss the session, you can just go through the session before you come to the next session. Okay.
Okay. In that Linux, does it cover only basic commands or else the admin part as well?
See, everything is admin here. If I just go to the syllabus quickly, my friend, Linux administration is there. It's not basics. So there is a package here. This is a package. See, this is what we'll cover. Maybe, 1 week or so basics will be there. Then we'll enter into the server administration part and the network administration part. We need to see everything like disk management, file permissions, user management, group management, sudo, okay, RPM, yum, DNF, process management, backup, automation, okay, networking concepts in Linux, NIC teaming, some servers. This is what we need to cover. It's not basics, it is your administration.
Okay. Okay. So as soon as CCNA is completed, so how long will be the gap for starting a new batch for Linux?
See,
So,
next week I'm starting a Linux batch. So in case if you want to come parallelly, it's up to you, my friend. You can come parallelly. It's not like, you have to
uh-huh.
complete CCNA first, then you have to come for, Linux. No, you can come parallelly in 2 batches and you can finish as early as possible.
So parallelly, what time it is?
Maybe next week I'll start a batch morning 7 a.m. India Standard Time.
7 a.m. Okay.
Morning 7 a.m.
So if you're starting, just let us know, okay, so that we can
Yeah,
attend.
yeah, yeah.
Okay.
Whenever we start the class, there's the reason I ping my WhatsApp number here. Just try to be in touch with me, or else the management will send you the details actually. Whenever we start a new batch, they will send you the message on WhatsApp as well as they will email you. So it's not a big deal to get all the details. Okay. Yeah, Praveen, I saw your message. Yeah, every day the class will be between 8 p.m. till 9 p.m., my friend. Daytime, as of now, not possible because, morning 6 till 10 a.m. classes will be there, and evening, 6 p.m. till 10 p.m. classes will be there. 6 a.m. till 10 a.m. and 6 p.m. till, let's say, 10 p.m. or 11 p.m. classes will be there. Daytime, it's very rare we start any class. As of now, it's March and April. So normally, in March and April, people are busy writing their exams, especially the college students. So we are not expecting many people in this batch. But still, we have already started the batch, so I have to continue this batch. But the timings will not change, maybe. Sorry to inform you, Praveen, but yeah, this is the way it works.
Also, just please make sure that, there are less holidays in between. So I see uh, usually in DurgaSoft, I see long gaps.
See, actually, minimum
And
5 days a week, we will try to cover the classes, minimum 5. In case if there is any festival in middle, then I'll take a class on Saturday also. So I'll just try to cover at least 5 classes a week. Okay.
and
And yeah, please go
and
ahead.
also, see, initially the batch will start at like, 10 members or so, but the end, right? So only 2 or 3 members will be there. So just make sure that, you are committed, like, even if it is a single person, yeah, please try to
See,
complete it. Yeah.
I got your point, my friend Mahesh. I have taken batches for a group of 70, 80 people, and I have taken a batch for one person also, my friend. So when I go with 70 people, my energy, my commitment will remain same for 70 people, or let's say one person. So there will not be any problem from my side. And why people miss classes, there is a reason actually. Most of the people are working people
Working,
actually.
I understand.
They are in touch
Also,
with me on WhatsApp. So in case if they miss the class, they come to me on WhatsApp to clear their doubts. So don't worry about my commitments and the things that I need to cover here. I'll make sure day one and the last day it remains same, at least from my side.
yeah, great. So another thing is that when coming to router or subnetting mask, so will there be any kind of simulation tools, or how will you try to show for those concepts?
See, there is a simulation here called Cisco Packet Tracer. I hope you can see it now within some seconds. Actually, see, this is a simulation software. Every person across the globe who is learning CCNA as of now, or who is trying to learn CCNA, or who is trying to, you know, go with some advanced courses in networking, they have to simply use this simulation. This is one of the simulation. There are many simulations available, and this is one of the simulation. It is called Cisco Packet Tracer. And by using this simulation, my friend, you can do literally all the practicals that you need to learn. Okay, let me just.
Is this a free tool or else,
It's a free tool. It's a
it-
free tool. You can simply use it, and you can simply, do all the practicals there.
okay. So
There
when
is,
we start this, right, try to please share this one as well, so that to the team. Okay.
yeah.
Yeah.
I'll share the link. You can simply create an account there by using an email ID, and you can simply download and you can install it. How to use it, I'll explain you.
Fine.
But
Fine.
how to install and how to download, it's a very basic thing. You should know this. So hopefully this is your simulation. If you can just go to this router here once, see what you see right now inside this router. This is what you see exactly in a physical router, a Cisco physical router. For example, if I say show IP interface brief here, someone across the globe, or maybe I can say some lakhs of administrator today, they have already used this command show IP interface brief, and they have already seen an output something like this. So this is a best way to do practice. No one can afford to take physical routers and switches. That will be too costly actually to make a home setup. So simulation is even not only for this, for Linux servers also we have this simulation. Oracle VirtualBox will be there. So here also we can install some softwares and we can do all the practicals. Okay. And
Yeah.
in case someone is interested in AWS, Amazon Web Services, for AWS also we have a free account. Free tier account will be there. So we can just go with this free tier account and we can do all the practicals there. So for every course, you have a simulation, my friend.
Okay.
Oh,
Yeah.
yeah.
Thank you. Thank you.
Yeah. Thanks a lot, friends. So that's it for the day. And yeah, see you again tomorrow at same time, 9 p.m. We have already started our session. So no looking back. Whatever number of people I get here, I just need to complete the course. 1 or 2 days here and there, I just need to complete the course on time. So like I said, every week, minimum 5 classes will be there. And in case if there is a holiday in between for some reason, I have to take a class on Saturday. Sundays will be off for sure.
Sure.
Shakeel, you take Azure also? Only Azure?
Azure, as of now, no, my friend. But hopefully within next 6 months, my plan
Okay.
is to make a package where AWS Azure will be there, Windows and Linux servers will be there, and CCNA will be there. If this package, if a person knows the importance of this particular package, then on day one only, I can say that person career is set. So this is such a big package. Like I said, as of now, I'm covering these things. Okay. Azure is the next thing. AWS and Azure, they are exactly same. They are the cloud services. They are the cloud service providers. These services are same. Everything is same. So there is nothing like I need to, go from scratch to the advanced level in Azure. Whatever I know in AWS, everything will remain same in Azure. The practicals will remain different. Services names can be different, but services use is same. And how we can use these services practically, that will be different. I know the use of Azure. I know the importance of Azure. So my next goal is actually to go with this Azure. And hopefully at the end of this year, this is my main goal, cyber security, my friend.
Okay. Thank you.
Yeah, that's it. Okay, fine. So that's it for the day, friends. See you tomorrow at same time, 9 p.m. India Standard Time with more about CCNA. Before I go, just try to make sure you practice the binary decimal binary conversion. Okay. Thanks a lot, friends. Bye. Take care.
Thank you.